All right, here we are in Unit 5. So our last unit, Unit 4, we did solving quadratics, and this time we're graphing them. So we'll be using the same sort of quadratic, which is y equals ax squared plus bx plus c. And when we graph it, it makes, the shape is a parabola. So this is what a parabola looks like. It will cross the x-axis 2 times, or it may cross 1 time, or it may never cross the x-axis, okay? So for example, if we had a parabola that crossed right at one spot, we had like one solution when we were doing solving quadratics, or we had imaginary solutions which don't ever cross the x-axis, okay? So most of the time, you're going to have 2 solutions. Okay, so we're doing the key features of parabolas, and the first thing that we want to learn about is our Y-intercept. Okay, so in Unit 1, or Secondary 1, you did X-intercepts, but you did linear equations. So you had like a graph that was something like this, and it would cross y-axis here and x-axis here, and we would write those down. But this time we're doing quadratics, so we still have one y-intercept. We'll always have one y-intercept, okay? And it's defined as the point where the graph crosses the y-axis. So if we look at this graph, the y-axis, or the y-intercept, is going to be this location. And we would write it as 0, because that's our x value, and then we'd have -3. All right, when we write down these ordered pairs, it's always going to be x comma y. So x is 0 for our y-intercept, and our y value is the -3. Okay, X-intercepts is the points or point where the graph crosses the x-axis. So we have 1 here at x equals -1 and at x equals 3. So we would write these down as -1 comma 0, because it crosses our y value is at 0, and our other one is going to be 3 comma 0. All right. Sorry, my voice is a little rough because I don't know. I'm not feeling super well. But anyways. Okay, axis of symmetry. Axis of symmetry is the line that cuts the parabola symmetrically, or like in half, okay? And it goes through what we call the vertex. So this dotted line is our axis of symmetry. Okay, and it's a line, so I'll write that here, line. Whereas our y-intercepts are points, or ordered pairs. Okay, and I guess that's just 1 point. All right, so axis of symmetry, if you look at that, it has to be an equation. It's got to be something equals something. And our line is going to go through 1, and it is always at the x location. So we would say x equals 1. All right, for all of your axis of symmetries, it will always be x equals wherever that axis of symmetry is, okay? Vertex, okay, this is also a point. Okay, it's the turning point of the parabola, or the point of inflection. So it's basically the point where the slope switches from negative. So if we look at this side, the slope is negative, and we're on the right side, the slope is positive. So this turning point is the point where the slope switches from positive to negative, or negative to positive. Okay, so this point, we write it as an ordered pair, and we would just find where the x value is at this point is going to be 1, and our y value is -4. All right. Okay, next we have max or minimum. So looking at this graph, is the vertex going to be a maximum or a minimum? Okay, so we look at the highest or lowest point, look at the vertex, and we would have a minimum. All right, if the graph was flipped over, then there would be a maximum. Okay? So, and then it asks, what is the max or min value? So the value is the y-coordinate of the vertex. So here at y would be, -4. All right, we'd have a maximum, and the maximum value would be a -4. There's not going to be any, the y is never going to be less than -4. So it's the minimum. All right. So there's one more thing that I didn't include in here, but oftentimes we'll have it in the homework and in the test. One of the things we'll say is, what is, let me get a different color. What is the x, no, that's not the one I want. X value that maximizes or minimizes the function. Okay, so it's basically asking, what is the x value that corresponds to the maximum or minimum point that we have here? So if we look at our minimum, which is part of our vertex right here, what is the x value that gives you that y value? So that would be our 1, our x value, so we just write 1. Okay, so more or less that max or min value, when you have that, when we ask for that, you're going to put in our y value in our vertex. And when we want the x value that maximizes or minimizes the function, it is going to be our x value in our vertex. All right? Okay, now domain and range. You should have done this in secondary 1, but we'll just review it really quick. Domain is all possible x values on the quadratic. Okay, so for domains, we'll scan from left to right. So this graph, I mean, this arrow is going this way, and you may say, well, it's going up. But as you see, the slope, it moves left a little bit, and it goes a lot up. So every time it goes up, it's also moving left. So eventually, as it goes infinity up, it's also going to be going infinity left, if that makes sense. And the same with the right. It would go to positive infinity. This would be negative infinity on the left. Okay? So domain will always be negative infinity to infinity. Always. Okay? We can also write it differently as this R, has like two lines going down and then just a regular R. And this symbol means the set of all real numbers. So this is exactly what we're writing here. All real numbers between negative infinity and infinity, which is the same thing as writing it like this. So either way, you're fine. You can also write it as negative infinity less than x less than infinity. All right, but most people would probably prefer those first two. Okay, just remember it's always there, okay? One thing we need to realize is that the parentheses in the Y-intercept and X-intercept in the vertex, those are points or ordered pairs. But when we're doing domain and range and increasing and decreasing, these are intervals. So they're not the same. It's not a ordered pair or a point. Okay, so this is a interval for all of these. Okay, why would you like a little circle? Right? So range is just like domain, except we're going y values. So we start at the bottom. So we'd start at the bottom of maybe this, and we'd go until we hit this vertex, which is over here, which is -4. So that's where we'd write our first y value, and we'd go to the last one, which goes up to infinity. Okay, so we'd do infinity. And so here's the one thing that we need to realize is that, remember what the difference is between a brackets, and a parenthesis, which is more like this, okay? A bracket tells us that the value that's right next to it includes that point. So if we look at this range, it starts at -4, and -4 is in that graph. So we include that. And you may say, well, why do we put parentheses around infinity? Well, we do parentheses around infinity because infinity is not a number, okay? You never reach a value. So infinity is not a value. Okay, increasing and decreasing, we want to start from left to right, okay? And we want to look at the y values, what the y values are doing as we move across this x-axis, okay? As we're moving left to right, the y value is decreasing, okay, until you get to the vertex. Or you could also say the slope is negative. So the slope is negative from -infinity to our x value 1, right here, okay? So we'd go to 1. And here we want to use parentheses for both. We want to use parentheses for 1 because at 1, the slope is no longer negative. It's not positive either. The slope is 0. So it is neither increasing or decreasing at that point. Okay, and then, or I should have that, or sorry, that should be the other way around because that's what we were doing, decreasing. Sorry if I messed you up. Okay, and then we go from that same point from our vertex, which is our x value is 1, and we continue going right. And as we go right, the slope is positive and y is increasing. So it's increasing from 1 to infinity. All right, and again, we put a parenthesis next to the 1 because the slope is not positive and it's not increasing at that exact point. The slope is 0 and it's not increasing or decreasing. All right, and then finally, direction of opening, it's either going to be concave up or concave down. So we look at this, look at the graph, and if it's smiling, that means it is concave up. And if it's frowning, then it's concave down. So here we just say concave up. Okay? And note, all intervals, these are our intervals, domain, range, and our increasing and decreasing. They're all done according to the x-axis, except for the range. So we would use x-axis, x-axis, y-axis, and x-axis. All right? So make sure when you're doing increasing and you go from this point until it stops decreasing, we don't put -4 in our, we don't put this value in. We put it into our x value. So from -infinity to 1, we don't ever do -infinity to our y value, which is -4. Okay. All right. It's probably a good time to pause and see if you guys can do these by yourself, and then watch me do it afterwards, or stop at any time, and once you feel comfortable, start doing the other ones, okay? So first thing we want to do is the X-intercepts. We have one here, and we have one here. Remember, we write them as x comma y. So the first is the x value is -2, and our y value for our x-intercepts will always be 0. And then our other one's going to be 4, 0. Y-intercept, we'll mark it. It's at 8. So our x value is 0, and our y value is 8. Axis of symmetry, it's always going to be the line that cuts the parabola in half. All right, so it's going to be x equals, it'll always be x equals, and then we want that y, or that x value that crosses the axis of symmetry that crosses the x value. Okay, so that would be 1. Vertex is the turning point, so it'll always go through, or the axis of symmetry always goes through that vertex. So we know our x value is 1, and our y value is 9. X or max or min, the vertex is a max, and what is the value? It is 9, so it's going to be our y value. Okay, domain, or one of the other questions we asked was the x value that maximizes or minimizes the function. So like we said, our our max or min value is our y value, and our x value that maximizes or minimizes the function is always going to be our 1, our x value in our vertex. Okay, domain, like I said, will always go -infinity to infinity, and you can also write that as that r with we draw 2 up lines. Okay, and then the range will start at -infinity, and we'll go all the way until we hit the vertex. Okay, so this one would go from -infinity to 9, and we would do a bracket because 9 is included on the vertex. Okay, increasing, so it would start from left to right. It is increasing until you get to the vertex, -infinity to 1. Remember, we're doing x-axis, and it's decreasing from 1 to infinity. Direction of opening is concave down. All right? Okay. Next example. So this time, in our first example, it was concave down. This time it's concave up. All right? Okay, so x-intercepts, we have 2, one at -1, 0, and we have at 3, 0. Y-intercepts, right here, would say 0, -3, because the x is at 0 and y is at -3. Axis of symmetry, we'll just draw a little line that goes right through it. Okay, and that gives us x equals 1. Vertex is the turning point. The x value of it will always be our axis of symmetry. And then our y value, we just look at the graph, and that would give us -4. All right? Are these exactly the same? No, they're not the same. Okay. All right. Is the vertex a max or min? It's a min because it's concave up. And that value is this value, which is -4. That's the minimum value of the graph. Okay. And then the max value that maximizes or minimizes the function, which would maybe put right in here, we would say that is 1. If you plug in 1 to this equation, it would give you a y of -4. Okay, domain will always go from -infinity to infinity. We can just write it like that, or like this. Okay, range will start from -infinity until we hit the vertex. So our first point is -4, and we'd include that value, and it continues to go to infinity, and we have a parenthesis at the end. Increasing, well, increasing starts at the vertex and goes to infinity. So we'd say 1 to infinity. Remember, this is using our x-axis. And decreasing goes from -infinity to 1. And direction of opening is concave up. All right. We just have a couple more examples. Okay, so here, X-intercept, you may be like, what? What am I supposed to put for this? Okay, if it's not crossing the x-axis, we would just say none. There'd be no x-axes. Okay, we can solve this equation like we did in our last unit, but we would have two imaginary solutions. Okay. All right. Y-intercept will always have that. Okay. Looks like it's not -2, it's not -3, so maybe we'll say it's going to be 0, -2.5. All right. Axis of symmetry, we draw that in, and we would call that, write it as an equation, x equals -1. So make sure when you're doing your homework and your quizzes and your tests, you need to always write x equals before you put the axis of symmetry. And the same with intercepts, you need to have those parentheses and a comma. Okay, otherwise you're going to lose points. Vertex, it's always going to be our axis of symmetry point for our x, and our y, we'll just look that up and we'll say it's -4 or -2. Max or min, we have a max because it's concave down. So, and then the value is our -2, and if we had an x value that maximizes or minimizes the function, we would write that in here and we'd say that's -1. Okay. Domain will always be -infinity to infinity, or this r value, or r symbol, that means the set of all real numbers. Range will start, the first point going from -infinity starts at a -infinity. All those points go down to -infinity. They never end. And our highest y value is our -2. Okay. Increasing, it increases from -infinity to our x value from our vertex, or our axis of symmetry, which is -1. And then it decreases from the axis of symmetry to infinity. And the direction is concave down. Okay? All right. Last example. Axis of symmetry, or I mean X-intercept, sorry. If you look at this one, we only have one axis of, or X-intercept, sorry. It's a day, right? So we would write that as our x value is a -2 and our y value is 0. The y-intercept is going to give us, our x value is 0 and our y value is 4. Axis of symmetry is going to be, we'll draw it, and it's going to be x equals -2. Vertex is going to be our y value, or our x value for our vertex is -2, and our y value is 0. You just have to look at the graph to come up with those numbers. Is there a max or a minimum? It's a min value because it is opening is concave up. And the max value, or I mean the minimum value, is 0. Domain always goes from -infinity to infinity. The range would start from -infinity and go until we hit our first point, which will be our vertex, our y value of our vertex, which is 0 to infinity. So I didn't really, well, let me finish this and I'll talk to you about one more thing. Increasing, so we starts increasing, the slope is positive starting at that vertex, which is -2 all the way to infinity, and it's decreasing from -infinity to the x point in the vertex, or the axis of symmetry. Okay? All right, there was one thing I wanted to also mention, is there's another way you can write the range. So let me just come to an example. Okay, so range, we can also write it as, because range uses our y-axis. Okay, you can also write this as y less than 9, less than or equal to 9. So all values of y that are less than or equal to 9. All right, for like this one, you would look at it and you'd say y, oops, sorry about that, y is greater than or equal to -4. Okay, or you could write this one as, oops, I messed up this right here. This should be a bracket. Okay, I imagine that a lot of people forget that on the test as well. So make sure, even I make mistakes like that, you can also write this as y is less than or equal to -2. And for this problem, I did it again. We need to have that bracket. We can also write that as y is greater than or equal to 0. Okay? So if you have any questions, let me know.